Hey folks, this is the second part of our graphing trig functions. This is the end of our unit 6. So last time we talked about how to sketch the 6 trig functions. So I'm going to encourage you to pause here and try to do all 6 of these on your own, and then come back and see how you did. All right, so hopefully you paused and you did it. I'm going to go fairly quickly here because if you aren't sure what I'm talking about, go back to last time's the notes 6.7. So sine starts at 0, goes up to 1. Remember, I'm looking at the y values for sine as I rotate around the unit circle, and then those repeat. And I connect it all with a smooth curve. Then we move on to cosine. Cosine looks at the x values. So at 0 radians, we have an x value of 1. And then as we rotate around the unit circle, we would get these as our x values. And then I would connect this all with a smooth curve. All right, now let's talk tangent. Tangent is is y over x. So I'm going to take the y values, I'm going to divide them by the x values. So when x equals 0, when radians are 0, y divided by x would be 0. Then when I rotate to 90, y divided by x is undefined. And then 0. And then undefined. And then 0. And so forth. And then we remember quadrant 1, tangent is positive in quadrant 1, so I want to make sure that in quadrant 1 corresponds to this gap here. I want to make sure my values are going positive. Quadrant 2 is negative, quadrant 3 is positive, quadrant 4 is negative, and then we have the fact that tangent is a periodic function to sketch the rest. So tangent should look something like that. Then as we move on to well, I guess we'll go to cosecant next. Seems like it's kind of weird out of order, but I guess it's underneath. The reciprocal functions are underneath the function that we're trying to sketch. So cosecant is the reciprocal of sine. So I'm going to start off by sketching all the sine values. So again, sine starts at 0. Then I'm going to take these sine values, I'm going to reciprocal them. So the reciprocal of 0 is undefined. Reciprocal of 1 is 1. 0 is undefined. Negative 1 is negative 1. Reciprocal of 0, undefined, undefined, undefined. And then as sine values get closer and closer to 0, when I reciprocal something close to 0, I get something that goes towards infinity. And so instead of having our curves point in and meet at 0, our curve ends up getting flipped out towards the infinities. Okay, next up, cosecant. Cosecant is the reciprocal of cosine. So I'm going to start off by sketching cosine. Cosine starts at 1. Then I'm going to reciprocal. And so all the zeros are going to become asymptotes. And then I'm going to take all those parts of the curve that were getting closer to 0, and then when I reciprocal them, they will get closer to the infinities. And last but not least, let's see how cotangent's doing. Cotangent is y over, my bad. It's the reciprocal of y over x, so it's x over y. So when I do x over y, 0 over 1 ends up being an asymptote. Did I say that right? cotangent is x over y. Oh, yeah. So it'll be 1 over 0. 1 over 0 is undefined. And then we get 0. Then we get an asymptote, and then we get a 0, asymptote, 0, asymptote. Quadrant 1 corresponds to this part of the graph between 0 and 90. That needs to be positive, so it's kind of weird. You draw backwards, up, forward, down. Okay, so now we've sketched all 6 parent functions for the trig functions. Now we're going to make some switches to them. So this was in the last time's notes. I didn't really refer to it because we didn't need it last time, but we're going to need it today. So we have this phrase called amplitude. Amplitude is how high the graph reaches. So all of these parent functions for sine and cosine had an amplitude. Really, we talk about amplitude for only sine and cosine. Sine and cosine have an amplitude of 1. Now, if I put a 2 out in front of this, we did that at yesterday's notes, or last time's notes, where we put a negative 2 out in front and then a negative 1/2 out in front. That's going to stretch or shrink our function, but the amplitudes are going to be the same. And then we have this other thing called I don't know why I said amplitudes are going to be the same. The amplitudes are going to change depending on what number's out front. So what number's out front, our coefficient is a 1. So that's going to, our sine curve is going to have an amplitude of 1. Notice it's absolute A, so I don't care if it's negative or positive. Your coefficient, if it's whatever the number is, absolute value, that's going to tell you the amplitude. Then we also have this value B. That tells you what the period is going to be. So last time our period was always 2 pi. We always considered it 1 lap around the unit circle. It's not the case anymore. We're going to look at different periods. So notice this is sine of 2x. That's going to change what our graph looks like. So let's add these to our unit circle. I guess I could squeeze it down here maybe if I wanted to. I think I'm just going to put it on the back maybe. Yeah, it's so small. I wish I could fit it on there, but oh well. The more I put on the front, the easier it is for me to find. So that's why I like to put it on the front, but whatever. So amplitude is absolute A, and then period is 2 pi over B. And if you want to write where those come from, so like f of x equals A, and I'm just going to put them together so I don't have to write them twice, sine or cosine of bx. All right, let's take a look. Now this is considerably sneakier than what we did last time, where we just graphed the parent functions. This one is a little bit trickier. So we first have to figure out what the period is going to be. So sine of f of x equals 1/2 sine of 2x. So the period is going to be 2 pi over b. So 2 pi over, what's the value connected to x? That's the b term. So that's a 2. 2 pi divided by 2 ends up being pi. So if my period is pi, that means I have to go a distance of pi, and then my graph should start repeating. So normally we want a distance of 2 pi, and then our graph started repeating. But now we're going to go a distance of pi. So that means it's going to be, our graph is going to have many more ups and downs, or troughs and valleys, or something like, I can't remember what that name is. So by the time we get to pi, our graph needs to have completed a full period or completed a full cycle. Well, when we sketch these, how many tick marks did we need to get to a full cycle? We needed 4 tick marks. I guess technically 5 from the one that you're starting, but I count it as gaps. How many gaps do we need? 1, 2, 3, 4. That corresponds to quadrant 1, quadrant 2, quadrant 3, quadrant 4. So as I look down here, I need to now divide this into 4 even sections. 1, 2, 3, 4. Now I have 4 even sections. And then I'm going to use that to complete one cycle of sine. Okay, so now I'm going to sketch sine, but I've got a multiplier of 1/2. So sine at 0 is 0, times 1/2 is still 0. But then it gets interesting. This is not 90. I know it's not. It's really a pi over 4, because this is pi over 2, so this would be pi over 4. But we're thinking about this as being the 90, because we've now done a horizontal stretch or shrink. In this case, it'd be a shrink of our function, of the sine curve. So in my head, I know this isn't 90, but I'm thinking of it as 90. So sine at 90 is 1. Our multiplier is 1/2. So 1 times 1/2, this would be at a height of 1/2. I know this isn't pi. I mean, I literally wrote pi right there. So I know it's not pi, but I'm thinking about it as pi. So pi there would be 0. 0 times 1/2 is still 0. And then this is 3 pi over 2 times 1/2 would be -1. This, and then back to 0. This then would become 1 period of this function. Now we have to repeat this for the whole, as far as we can graph on the grid that was given to us. So this coordinate plane goes all the way to 4 pi. So what I'm going to do now is I'm going to go through and I'm going to add each quadrant. I'm going to divide each section into 4 tick marks. So there's another period. 1, 2, 3, 4. There's another period. Okay, so where is this? This is 3 pi. And then 1, 2, 3, 4. And then this is 1 period, so we're going to cycle that over and over again, a length of 4 dots. So 1 tick mark, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then finally we can connect that all with a smooth curve. So this is a shrink, a horizontal shrink compared to the original parent function. If you took the parent function and shrunk it down, you would be able to fit more cycles from 0 to 4 pi. All right, let's try it again. Let's try it for cosine. So we've got negative cosine of 4x. Yeah, we probably should do this together. You can try to pause if you think that you're ready. If you want to try to pause and do it on your own, go for it. I'm guessing that we need to talk a little bit more before you're ready. So I'm going to first figure out what the period is. The period is always calculated using the same formula, 2 pi over b. And in this case, b is 4. B is always the term that's connected to x. I reduce, I get pi over 2. That means that my cosine curve should complete 1 full cycle, should complete 1 full period by the time it gets to pi over 2. So now I got to figure out where's pi over 2. So this is 2 pi. So this is pi. So this then would be pi over 2. Oh boy, this is going to be tough. That means I have to divide this into the 4 quadrants, have to get divided before I get to this spot. So I recommend cutting it in half first, and then cutting that in half on either side. So that's probably the best way to relatively evenly cut up the quadrants. All right, we're doing cosine, and we've got a multiplier of -1. So cosine usually starts at 1. So when I take 1 and I multiply it by -1, I'm going to start here. Then I'm going to rotate around the unit circle. My next value would be 0, but I'm multiplying by -1. 0 times -1 is 0. My next value for cosine would be -1. We have a multiplier of -1, so we would get +1. Then 0, and then -1. This then would be 1 cycle. Ooh, boy, that was really bad. I basically missed that whole point, but hopefully you get the idea. There's 1 cycle, 1 period of cosine. Now we have to fit as many as we can on the grid that we're given. So now I'm going to go back and I'm going to take each section and I'm going to divide it into 4 sections. That means I need to add 3 tick marks. 3 tick marks makes 4 sections. And then I'm going to repeat this cycle over and over and over again for cosine. -1, 0, 1, 0, -1. 0, 1, 0, -1. 0, 1, 0, -1. Then I'm going to try to connect all of these with a smooth curve. They look better at the end than they do at the beginning, but that's all right. So one thing I want to point out, do you remember when we did shifts, transformation of functions, and we did shifts, and the thing next to x always did the opposite of what it said? It's still the same process, same property here. This 2 is connected to the x by mult, so you'd think that would stretch everything out by 2, but it always does the inverse of what it says. So if it really multiplies by 2 to the x, that means that my graph actually gets shrunk by 2, gets divided by 2. That's why there are, so like in this, when I did the parent function for sine, there were 2 complete cycles to get to 4 pi. When I put a 2 in there, notice there are 1, 2, 3, 4 complete cycles. And when I take 4, there's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8 complete cycles to get there. Okay, let's do one where we have a period shift or change of transformation of 1/2. So this is going to take my graph, just like I said up here, when I do a multiply by 2, it actually divides by 2. So when I divide by 2, it's actually going to multiply by 2. So instead of having 2 cycles, 2 periods within 4 pi, I'm going to only have 1 period. It's going to take my graph, it's going to stretch it out in the horizontal direction. So let's start with identifying the period again. I think that's the best way to attack this. So my period is 2 pi over b. 2 pi over. Now b is the number that's connected to x. It's the coefficient of x. So it doesn't seem like it, but there is a 1 here and the 2. You've got to take both of those into account. So my b value is 1/2. We all know that you can't divide by a fraction, so we flip and multiply instead. So 4 pi is 1 period. That means that I want to take the gap from 0 to 4 pi, and I want to divide it into 4 equal sections. Just like I did up here, I took from 0 to pi over 2 and divided it into 4 equal sections. I'm going to take 0 to 4 pi and divide it into 4. But the best way to do that is to cut it in half once, and then cut each one of those in half again. So now I have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we are sketching cosine. Notice we have a multiplier of 2. So cosine, when 0 radians is 1, but I'm multiplying by 2, so that would be 2. Then it rotates around to 0. Rotates around to 0. Notice I messed up. I don't want to put the tick mark there. These are each one of my quadrants, so I fell for it. This is my next quadrant. So from here, cosine rotates. Cosine does 1, 0, -1, 0, 1. So I'm going to do the same, but I'm going to have these as being my 90 degrees, even though I know they're not. For graphing purposes, I'm going to pretend like they are. And so I get this curve, connect it with a smooth curve, this stretched out cosine graph. Notice here's the regular cosine curve from 0 to 4 pi. How many periods? We get in 2 cycles. From 0 to 4 pi, how many periods? How many cycles? We only get in 1 cycle because our period was twice as long. Okay, let's talk about our last one here before we get into the reciprocal trigs is sine of pi over 4. So I'm going to start off by looking at what the period would be. The period is 2 pi over, my coefficient is 1/4. flip and multiply. So 8 pi is the period. Now look, we don't go to 8 pi. We only go to 4 pi. So for me to get to 8 pi, I would need to divide that into 4 equal sections. So how big would a section be? 2 pi to 4 pi, and then that's going to be the end of my graph. So I'm not even going to have enough room on this grid to be able to get to 8 pi. I'm not going to be able to get one full cycle in. That's okay. That's our stretch factor. So we're talking about sine. Sine, we have a multiplier of 1, so that's nice. This corresponds to 0 radians. So sine at 0 is 0. Then I move all the way here. This is 90. I know it's not really 90, but if I take 8 pi, which is my period, and divide it into 4 even sections to represent each one of the quadrants, then 0 to 2 pi is 1 quadrant. So then sine is 1, and then sine is 0. So this is all I get. I get just this portion from 0 to pi. I get half of 1 cycle. Now, if I continued my graph out to 8 pi, it would go down and then come back up to make the sine curve. Let's see if you can do the next two. Let's try, well, do one at a time and then come back and let's check in to see how you did. All right, let's see here. So let's take a look at, all right, so first of all, I've got to remember that secant is the reciprocal of cosine. So really, I'm going to be sketching cosine here. Now, what's the period? Period is 2 pi over 2. I get that from this value here. 2 pi over 2 ends up being pi. So 1 period is pi. So I want to go a distance of pi, and then I need to divide that into 4 equal sections. So that's 1, 2, 3. Now I have 4 equal sections. This time I'm going to continue it. So there's another gap of pi. Cut that into 4 even pieces. Another gap of pi to 3 pi. 4 even pieces. And then 4 pi. All right, so now I've got all my tick marks figured out. So from 0 to pi, I should have 1 full cycle. Now I'm going to sketch the graph of cosine with a multiplier of 1/2. So cosine starts up at 1, but it's getting multiplied by 1/2. So here's my first point. Then we go to 0. Well, that's going to turn into now I can go ahead and just sketch it. 0, then -1, then 0, and then 1. Now, don't forget, you have to reciprocal this. This is not the graph of cosine. This is the graph of the reciprocal of cosine. So then these are going to turn into asymptotes because they have an x or y value of 0. And I'm going to go ahead and just, so point, then asymptote. I'm going to just sketch all my asymptotes now. Okay, and then we started up at 1, go down to 0, then go down to -1, but it's got a half factor. Up, then 1, then 0, then -1, then up, then +1, then 0, then -1, then +1. And in quadrant 1, cosine should be headed towards 0, so this should be headed towards positive infinity. These would head towards the negative infinities, and so on. There you go. All right, let's try the last one here. Cosecant is really the reciprocal of sine. So I'm going to pretend like I'm looking at this from the sine perspective, and I'm going to reciprocal all those values. The period is 2 pi over 1/2, which flips and multiplies and becomes 4 pi. So 4 pi should be 1 period. So 4 pi is right here. I'm going to cut that in half, and then I'm going to cut that in half again. So these are my 4 sections, from pi to 2 pi to 3 pi. We're graphing sine, but we've got a multiplier of -3. So sine starts at 0. When you multiply by -3, it's still 0. Then I'm going to go to my next, multiply by -3. Should be 1, but I'm going to multiply by -3, so it's going to be -3. Then 0. Then -1 times -3 is +3, and then 0. And then reciprocal each one of those. Oh, I meant to do those in purple, but that's all right. So then my zeros become asymptotes because we're doing the reciprocal of sine. And then now this section, instead of heading towards 0, it's going to head towards the infinities. So your graph should look something. Oh, those aren't my best curves I've ever drawn, but we'll live with it. So now you should be able to sketch the parent functions for all 6. Notice I didn't have you shift these. I'm not going to have you transform those at all, really. Maybe I'll throw a negative in there. I guess I shouldn't say that. I could throw a negative in there because I think you guys can handle reflections, but I'm not going to do any scale shifts on those. So it's not going to change the period on any of those. But these other ones, I expect you to be able to handle any sort of changes to the period. All right, guys, good luck.